Hi everyone, you're very welcome to the iAtelier talk. We're just going to give it a minute or so to let everyone come in and then we'll begin. Thanks again for joining us.
Okay, folks, hello again, and welcome to our 7th talk in the iAtelier Expert Talk series. Again, my name is Michael Mclaughlin. I'm lecturer in digital design, digital fabrication at Limerick School of Art and Design. So today we have Drummond Masterton, who is the current head of School of Architecture and Design at Falmouth University. Drummond trained as a 3D designer at Gray's School of Art, Aberdeen, and at postgraduate level at the Royal College of Art in London. His digitally designed and manufactured craft pieces have been selected for a number of major European and UK exhibitions. He also has several key pieces of work in national collections, including Royal Scottish Museum, Edinburgh, and the Crafts Council in London. Drummond's craft is the result of several years experimenting and practicing with CNC metal milling processes, among other processes. By creating user-defined toolpaths, he overrides software presets and gains complete control over the movement of the cutting tool, producing unique, intricate shapes, surface textures, and patterns. For me, I think Drummond is an example of somebody that has managed to develop a unique workflow that gives him huge creative control over a digital fabrication machine and machining processes that often would be described as quite a rigid engineering process. So Drummond, we are delighted to hear more from you, and you can share your screen whenever you want and get started. And just a reminder again to everybody else that you can add your questions in the Q&A at the bottom of your screen. Thank you, Drummond.
Thanks for that introduction, Michael. Give us a second and I will share my screen. Okay, hopefully somebody can say that they can see that rather than me just talking along.
Anything at the moment, Drummond, if you want to try again.
Oh, okay, no problem.
Just that green share screen button that you had earlier.
Oh, yeah, there you go.
Yep, that's it, Drummond.
It's just blank at the moment, though. Have you got? There we go. Perfect.
Yeah, no problem. Must be that Cornish lag. We're doing it directly from Cornwall today on BT's best fibre. So thank you very much for joining me and for Michael's introduction. Really kind of humbling to hear yourself described as that. So thank you for that intro. Yeah, I'm going to talk about my practice, and I've kind of gone for a kind of a historical narrative today, taking you through, where I've come from as a person. I think, the more and more I've listened to people talk over the years, 20 years lecturing in academia and being a maker, the more interested I've been in what are the backstories to people, what is it that's got them to the point they've been, where did they grow up, what were they interested in? I think that helps kind of gain an understanding of the person that you don't necessarily get from just a straight talk of work. Sometimes the work can be slightly overwhelming or overpowering in that sense. So this is me. This is what I love doing, cycling. This is probably like the #1 love of my life. This is me in my happy place, if you want to call it that, in Bassano in Italy, and a couple of years ago on a gravel tour around Italy. And generally cycling has kind of been a fundamental part of my life since I got run over when I was a kid. I got run over when I was about 12, playing football with my mates on a cul-de-sac, which probably was a really bad idea. Got into a fight with one of them and ran in front of a car and was in a coma for a month in hospital. And these kind of stories are kind of quite interesting, because when I woke up, my left, right brain and ability to control other sides of my body had completely kind of unwired itself. And they taught me how to gain back that control by playing Sega's first version of things like Duck Hunt in hospital. So I had a month playing Duck Hunt, and it's a little wonder that I haven't turned into some kind of crazy killer. So it's just as well I found craft, I think, otherwise I'd be out hunting ducks for a living. So that's a little story about my digital ingraining in the NHS. Most of my weekends as a child were spent wandering up and down mountains in Scotland with my parents. I think I climbed all the Munros in Scotland, hills over 3,000 feet by the time I was about 14, and I'd given up any kind of interest in going on car journeys with my parents to do that. But, you know, looking back on that time, you know, the number of extreme landscapes and amazing places that I saw at an early age, you know, these geological fantastic places like Torridon that we're looking at here, you know, seem like they're out of a movie setting. Really kind of you know, sat with me for a long time, and I suppose alongside that, things like map reading and, you know, kind of contemplation time. You know, as a child, I was an only child. I had a lot of time to myself. I used to paint a lot of Warhammer miniatures. We might call that craft these days. I certainly interview a lot of students these days that have portfolios of Warhammer miniatures. So we get a good rapport there. I think, you know, space to think is one of those kind of undervalued things. And you know, maybe something that the pandemic has shown us recently is actually space to think can be a really healthy thing as well. It gives you space to develop ideas, and space to become independent in the way that you do that as an artist. And just to kind of flip that completely on its head, the other side of my life was, you know, running away from home, jumping on buses at the weekend and going to raves, you know, generally without my parents' knowledge. So, you know, this was kind of like a dual-sided world of, you know, kind of being the good only child and then being the runaway terror, and indulging myself in kind of rave and acid culture in the kind of early 90s. And, you know, music has been, you know, kind of instrumental to the way that I've approached digital craft in itself, in the way that things like electronic music deconstructs scores and uses kind of innovative machines, Roland 303, 808, to make noises that, you know, we hadn't heard in those days. And, you know, those things, again, became part of my interests. And then I think the making side of me, well, it comes from several places, but, you know, strangely enough, mountain biking was one of the things that I enjoyed doing a lot with my friends. And mountain biking in early 90s, late 80s was kind of just starting in Scotland, and it was mainly influenced by kind of American culture, lots of kind of high-tech engineering companies, creating kind of anodized, highly engineered components. The example in the right-hand corner is actually a British company, Pace, made this amazing kind of box section bike that we all kind of lusted after. And none of us had the money to do these sorts of things. So we used to kind of go to my mate's garage, get out drills, drill things to make them lighter, sand them, polish them with a, you know, kind of like a polishing mop on my dad's drill. And we used to have like a kind of, you know, like a prized duck down polishing mop that would get it like ultra shiny. So I think, you know, those kind of early days of understanding metal, how to work with aluminium and titanium, really kind of started in my mate's garage when I was kind of like 14 and 15, hacking away at bits of bike and inevitably breaking them or doing ourselves some great injuries. And I think, you know, this is an interesting expression of kind of culture and engineering coming together in that space of mountain biking. Sci-fi was also a massive influence in my life. You know, this kind of scene from 2001, that kind of understanding that that humans could hack technology, humans could always kind of interrupt the intended path of technology. And, you know, we see Dave in 2001 taking apart Hal, and Hal slowly kind of losing his consciousness. And And then, in Blade Runner, obviously Decker contemplating, what's real and does it really matter anyway? And those kind of principles kind of came back into my work eventually, as you'll see later on in this story. So where does the digital come from? Well, my dad was a graphic designer in the council. That was his work. And growing up in just outside of Paisley in the kind of 80s Thatcher years, often working on Saturdays was part of the normal. I would go into his office, and I remember they shifted from a pen and paper office in about 1989, 1990 to Corel Suite. And I often, got to sit there and play unchecked with, Corel. And that kind of lack of structure, the lack of having manuals, the lack of having anybody to show you how to do something, I suppose really just kind of fed my thirst to play, to break, to be inquisitive about digital tools. And that's really helped me kind of understand how to be innovative with these kind of not following manuals is fundamental for me. I then got a place in art college after doing a really kind of overly purple series. I won't show you that today, purple pastels and watercolors from my portfolio. And I ended up kind of doing a lot of hand making at Grey School of Art. So from 94 to about 97, I mainly made highly precise kind of engineered pieces of really horrible jewellery like this that you would never want to wear. I suppose kind of inspired by David Watkins at the time. Not sure anybody would want to wear a David Watkins piece either, but they're beautiful to look at. So, and it really was about, I suppose, kind of engineering practices, marking out, piercing saws, filing, using things like structural glue, which was really frowned upon at the time. Why weren't you soldering things? And this all leans back to my mountain biking times of aluminium. And, bikes were glued together. So why wouldn't you glue your work together? It just kind of seemed natural. You can hold an airplane together with it. Surely it's good enough for a bit of jewellery. And then the kind of finishing techniques of things like sandblasting, plating, anodizing, surface treatments to achieve different textures. Until I bumped into this tutor at the time, Gordon Burnett, and this was my first kind of earliest introduction to how to take the 2D digital into 3D digital. So kind of moving from having ideas in Corel and being able to output them as graphic, but not being able to interpret them directly as 3D, to seeing Gordon's work in these clocks and timepieces that he became kind of well known for making. And he introduced me to one of these, which is a Heidenhain CNC control, which was completely alien to me at the time. But I think, as you'll see, I like the challenge of these things. And I made this my final year kind of project to kind of understand, how do you work with one of these? What can it do? How can you join creativity to digital, to 2D digital to 3D digital? And again, what was so nice about Gordon was he kind of gave me like a 30-minute, this is what you do roughly. This button does this and that button does that. Don't touch this button, I'll break it. Go away and have a play. And I think it's so important to have tutors with that sort of level of competence to enable you to do that. Because it lets you be your own person. I didn't want to be a Gordon Burnett, and I don't think Gordon would have wanted me to be a Gordon. And I think that's a really crucial thing in educational structures. And of course, I made some really bad, disastrous, horrible things in the early days. This is the very first CNC thing I ever milled. So you're getting to see some rare stuff I've never brought out of the archive today. This was a piece of MDF that I think I'd had a tutorial with someone like Thomas Heatherwick at the time. And he said to me, you should go really big and you should make inflatables and put them over, like the main road in Aberdeen. It'll be great. And I was like, yeah, it'll be great, won't it? And was really convinced that this would be great. and looking back on it, it really wasn't great. Had some fun, learned a lot, did a lot of damage, burnt a lot of tools, bits of wood, drilled a lot of beds. I think there isn't anyone who's used a CNC mill that hasn't, drilled a hole in the bed at some point, in a way of kind of leaving your signature on your machines. And eventually, those trial and errors led to kind of, more control of those processes and more understanding of those processes, and starting to kind of work with some of the anomalies that I could see within the software, in this particular piece of software, QuickSurf, the ability to not have G continuous surfaces, so G0 or G1 is what they're called, mainly in automotive. Doesn't allow a surface to fold back on itself. So I started trying to get it to do that, being a difficult, awkward, stubborn Scot. I was like, no, you will do it. And ended up creating these really kind of interesting optical patterns in acrylic. And sometimes there was little fleeting bursts with function. This was a credit card case I made at the time, mainly through wanting to have something unique myself. To put in my pocket to go out at night, and ultimately a lot of kind of what became a lot more sculptural work. So this piece was one of the first pieces that made it to private collection with Charmian Adams. Bought this in '98 after seeing it at New Designers, believe it or not, a long time ago. And a lot of my work is sculptural rather than functional. And you see that going forwards. I then moved to London. I was working in a bike shop in the middle of the summer after finishing at uni, going to wonder what that was all about. No different to today. Gordon phoned me up. He said, "What are you doing?" And I said, "Working in a bike shop. It's quite good to get paid cash in hand, 25 quid. It's nice." And he said, "You should really get your life sorted out. You want to go down to the Royal College, take your portfolio." I think he probably lined up some things for me. So, bless him. I don't think I would have got there if it wasn't for his inputs. And I went down there and I got a place. And then within a week, I had to find somewhere to live, which is another story for another time. And I think when I got to London, I think I'd visited London with my dad. My uncle used to work for Liberties, and we used to stay in his flat off of Oxford Street. So as a child, I kind of knew London, but living in London and visiting London are two different things. And I think, the over-consuming nature of the city definitely kind of consumed me, being at the Royal College, working, 7 days a week, all hours. And I think maps became central to kind of my way of escaping that kind of reality. So when I needed a breath of fresh air, I'd kind of dig out my old maps and have a look at the places that I'd been as a child and kind of revisit them in my mind. Don't know why I didn't just get on the train, but obvious things like that don't really occur to you at the time. And map making is really beautiful, and we can see over the years of what's been lost. We don't see these lovely marks that they make on these locks and sea areas now. We just get that lovely blue color instead. And things like these started to translate into my work. Made a series of kind of drawings from memory of places, making my own maps. And that became quite important to kind of understand that I could make 3D things, and I could probably just go and get some GIS data and pull down Ben Nevis or pull down a bit of the Alps. But that kind of like use of other people's data and the ease of doing it just didn't appeal to me. It's always been kind of like, always take the hard way. So I hand drew all my maps line by line, so that the image on the left is pencil drawn with layers of tracing paper, and then the image on the right is the digital file, which was drawn with I suppose vector dropping on a pencil file in Form Z with a high sample rate to try and create that same kind of stuttering hand mark you get from pencil making. I just found that those sorts of things added extra kind of levels of detail to the models I was making. There was some new technologies at the Royal College. There's 3D printing. This was '98. This was a machine that had sat there doing nothing until I got there, I think. And they basically just gave me free rein to mess around with it, which I did, and started making these parts which were cast in silver, taking ridiculous amounts of time, hundreds of hours to make these objects in wax, never mind cast and finish them and everything else. But I started to kind of be the technician, the engineer, the craftsperson, the digital designer, all of it in one. And I could see some of the advantages of that by being able to stop the machine layer on layer and kind of intervene manually in processes, and just being able to open a lid and mess around inside the machine and not have anyone tell you not to. It was kind of quite a nice liberating feeling. I then moved to Falmouth University in about 2000, and for 5 years I didn't make anything. I didn't lift a bit of pen. I must have been burnt out from all of that time, and I think also just learning how to be a lecturer. I think it comes to all of us. You have to understand teaching pedagogy, and that's another challenge in life. In about 2005, Katie Bennell, Dr. Katie Bennell was at Falmouth, and myself and Katie, we started working in a research cluster that she set up called Autonomatic, and you'll have heard from Taus earlier if you were on the call on last week, I think it was, yeah. Taus was speaking, and Taus and Justin Marshall joined that centre. And I think the thing that was really instrumental here was, European development funding money invested in our area, because it was a regional development area. And we were able to procure 3D printing and CNC milling machines that were, really kind of special machines at the time, kind of 80, 90,000 pound plus machines, and have direct access to them. And, opportunities to invest in craft practice and digital practice really thrive when there are resources and the environment around you to do that. And I think, Katie did a fantastic job of setting that up at Falmouth. So I set myself this as a research associate at the time, a project for about 4 years, which was working alongside some partners in Dundee, looking at digital interfaces. And I thought I'd show you my studio, because everyone talks about studio. I've never had a studio, but this is probably my studio. So this is the on button. This is every time I go to make a piece of work, this is the thing that stares you down, a bit like HAL 9000's eye, and dares you to press it. Once you've pressed this button, there's no going back. Obviously, I wanted to have an approach to digital that was about risk taking, and that's a difficult thing. It's an easy thing to say, but a difficult thing to do. I think when you work within institutions, or even when you work in private companies, taking risks it's kind of not frowned upon, but we put measures in place to make sure risks are not part of the everyday, because risks are expensive. We break things, we damage things, we can hurt people. But risk taking was really fundamental to me understanding these machineries through my own personal perspective engagement, not through a technician, not through an engineer. So I think, as Michael was speaking about developing this kind of understanding of the technology, it was really fundamental that I could interact with these on pretty much a daily basis. So, I could finish teaching practice. I could be here till 8 or 9 o'clock at night and be working on this machine, this Bridgeport machine you see in the top left. And, when we got this machine, there wasn't any manuals. And it was one of those kind of cases of, I know how to work it. Yeah, that's fine. And I remember finding my sketchbook from 1997, and I'd drawn every single one of these little icons on this hide and hind control, and they're still the same today. And that's what's so lovely about it. I was like, it's the same. I know how this works. So, that was quite amazing to realize that not much had changed in kind of 18 odd years. Obviously, you know, these machines, CNC machines, are rooted in engineering. I remember visiting Leicester to do training on the Bridgeport and stepping into a machine that was about 10 times bigger than this machine that was for milling airplane blades, turbine impellers. And, you know, you're just getting that sense of scale, sense of speed. You know, these machines traveling at anywhere between 20 meters to 40 meters a minute, tool speed. Frightening when they're running at full speed. The noise, you know, highly loud compressed air, usually kind of 9 bar running the bearings. The coolant systems to keep everything at temperature or running temperature. And this is when I realized that, you know, that craft had been an insular kind of solo practice for me up until that point, and actually reaching out to other disciplines, engineering disciplines, material experts, tooling experts who make the tools in Japan, Germany, people like Mitsubishi, people like Showa, were absolutely fundamental to understanding what the capabilities of these were, how to use them within a range of, you know, good working range, and then I suppose knowing how to go beyond those ranges. So I suppose know something and then know how to undo it. And one person that was always on the phone was Andrew Wright, who was this kind of really grumpy engineer I met in Leicester, in Bridgeport. Hopefully he's still working there. He's fantastic. He's probably the only engineer that happened to know all of the features of the machine. And you'd phone him up and he'd go, yeah, what do you want? And you'd be like, yeah, Andrew, just having a problem with getting the spindle to turn on today. Yeah, that's on page 92, line 4010. Just need to put in x.-.1. Bye. You'd be like, yeah, I think I got that. And so, you know, multiple talking with Andrew really helps me kind of understand all of the hidden features within these machines. I think there are the simple features, and then layers of kind of thermal compensation, layers of arc compensation, electrical compensation that started to add more and more complexity to my understanding of craft knowledge and language. This is my tool cupboard where all the lovely tools, cutting tools are kept, and bolts and verniers and all sorts. And I suppose, you know, the number one tool for me over the years has been a feeler gauge, which I think if anyone had asked me what a feeler gauge was when I was doing my undergraduate, I wouldn't have had a clue. But a feeler gauge has become one of the central tools to using these machines. And that's kind of a funny thing because it's a very manual engineering tool, a feeler gauge. And these bits of machinery, they have a lot of advanced digital tools you can use to laser scan things, to measure things. But as we go through the rest of the work pictures, see some of the challenges that I came up against, where basically handheld measuring became some of the only ways that I could be certain that I wasn't going to damage something that I'd made. So I had this machine, and again, you know, playing with it. Certainly we did some playing with it, and you know, some really quite boring stuff came out at the start. And then we had this talk. It was just a talk with Katie one night. We just saying, "No, you know, imagine if you could see your dreams inside your cup of coffee, your cup of tea." That was it. It was just a simple conversation, and I just went and made that, made it in metal form, so crystallized the idea into aluminium, and it was a huge challenge. I CAD modeled this piece, and it's Ben Nevis in a kind of 1960s melamine, I can't remember the name of the company, coffee cup that I found in a charity shop, and it's the cup I drunk coffee out of every day. And Ben Nevis is the place that I was dreaming about most of the time, being somewhere really mountainous. You live in Falmouth and you come from Scotland, there's not many mountains. And underneath the cup, I haven't got a picture of it here, but there's an interlocking Ben Nevis that also locks into the cup. So cup and the saucer had to interlock perfectly, positive and negative, which is more challenging than you might imagine because tool cutters are round and they don't make sharp negative shapes. So having to use extremely small cutters down to kind of 0.3 millimeters to achieve that interlock. And the handle, machining around the handle was very complicated. This isn't a thing that you should probably ever CNC machine. So there was lots of technical challenges which were there for the learning, and trying to do something that was kind of unachievable by other forms, kind of things that would surprise people, was definitely something that became important. And I think speaking with Louise Valentine in Dundee as part of my craft project, we were talking about you can't assume that innovation just exists in craft because you see something unusual. So when you see something unexpected or unusual, it doesn't necessarily mean it's got innovation in the innovation. It is so much more deeper than that. Did a kind of project that was looking at tessellation. Obviously, if you're into digital modeling, at some point you probably question, why do we have triangles on everything? Again, some good reasons coming back to map making, but we started to see a lot of digital forms in kind of like the 2007s to 11s, lots of triangles over everything, lots of people claiming the triangle was theirs. It's a bit like Bridget Riley's stripes, and I kind of just wanted to develop new topographic meshes to kind of start to try and escape some of those triangles or be able to control them in a way. I think, as a craftsperson, having control over all aspects, whether you choose to exercise them or not, is quite important. I think at the time I probably wanted to control everything too much, and sometimes that did result in kind of some stale work at times, something that wasn't that exciting. And as I developed, confidence as a maker, I started to kind of question how much to control and when to stop and look and change direction. Some incredible patterning that I would do, which would sometimes the machining would take a matter of an hour, and other times it would take days. And if the machining took an hour, usually the CAD, the digital files would take days. So there was no easy winning here. And this one, which I suppose difficult to see the details here because it's quite a large piece, has these kind of Islamic complex patterns going on, and they keep repeating like a fractal in. And every single zone within each of these kind of diamond shapes was individually created for this piece. So automation is one of those big areas in CNC and digital work. And if you go into a machine shop, anywhere where they're making things, it's repeat programs. It's using computer-aided manufacture software to create software programs that can be run by operators. And I was really interested in how can I make the actual machine code myself. Not being a coder, I didn't necessarily want to write code in that sense, but I wanted to feel that I had control over where the tool path went, because there was a language of what you had designed in CAD. There was then an understanding that by cutting the metal, that changed. It wasn't you saw the end result in CAD and then the machine made it. The choice of the tool, the choice of the step over that the tool makes, all relate to the kind of finished aesthetic. And I kind of, that was the point at which I kind of then goes, I need to be able to control that factor of making cut paths. So I ended up hand drawing, using the tools that I knew to hand draw every single one of the tool paths. And I found a very old Hewlett-Packard graphics print driver that let me do that. So a lot of the time it was about taking a technique, but then working out how to interpret the data back into a CNC file. And the nice thing about digital languages is some of them have been very open over the years, and you've been able to go in and use them for other purposes. And the Hewlett-Packard plot file, the PLT file, is one such very open file. I think, you know, that's something that we see less and less of these days in more mature software. The systems are quite locked down now. Some kind of elements of tactility. So again, a kind of fleeting functional kind of aspect. I needed a pen case, so I made one. It gave me a space and a surface to explore these hand making marks, because I thought, well, if I'm making cut files that are like the computer does, why don't I just make cut lines that are like an engraver would or like a printmaker might? So I started just hand drawing directly onto my CAD files the line I wanted the cutter to take. And you can see that on this kind of arc crescent shapes on that pen case. Some piece I did for the National Metalwork Collection. It was modelled on bit of Snake Pass at Derwentwater, where they flooded the reservoir near Sheffield. Satin oak. Couple of statements that I always have held true to. You know, traditional makers, you know, they understand the tools and the materials they work with through, you know, years and years of hands-on tacit experience and other technical and scientific knowledge bases. And through that, they can make unique vocabularies, and it's no different for digital makers. It requires investment in time, investment in each aspect of the tools you're using. And if you let any one of those bits slip off of the radar, or you choose not to kind of engage with it, I suppose ultimately you lose opportunities to be further creative. So kind of, I suppose it ended up doing like an engineering apprenticeship myself, by starting to learn what sort of marks tools would make. So I made a huge database of aluminium with these passovers. So this is a 0.7 passover and a 1.08 passover, and you can see visually the difference here. And there were sheets and sheets of this, and this kind of gave me a way of creating a palette, you know, of surface textures that I could call on, so that when I started to design a piece, I had some ready-made kind of palettes that I understood what sort of results I could achieve. And then over the years applied a kind of printmaking technique to that, looking at cross-hatching and overcutting, and using fractional depth differences here. So something like 100th to 1,000th of a millimeter differences in height, to achieve these kind of these overcut patterns. One of the important things to say here is thermal compensation, thermal control in metal becomes really important when you're working at those you know, nanoscales. You know, it works on one day and it doesn't on another day, and you start to wonder why, and it's because the cutting coolant has gone up by 3 degrees because it's been a warm summer, and little things like that. You have to have the details on lots of things to get repeatability. Doing things that aren't meant to happen. You know, I think that's a really important thing to state, is, you know, just because there's a way of doing something doesn't mean you shouldn't question that and do it a different way. So this is a cut file flattened, so a 3D thing squished into a 2D thing, and all layers cut on the same level. And these marks that you see are the directions that the tool travels to get to other places, usually called the clearing plane. So they're movements that we never see the machine make in a finished piece. So trying to reveal parts of the process. And I think, you know, craft's about that. You can hide things, you can pretend that things are other things, and then you can reveal things. And, you know, that becomes a tool to play with. I think that this is the best thing that anyone's ever said to me. I was at an exhibition this piece was on, and this Japanese girl came up to me and she said, "This looks like it's come from outer space." And I was like, "That's exactly what I wanted someone to say." I liked collecting meteorites, and I loved the patterns from Woodman-Staton patterning in the iron. It heats up, and I was like, how could I get something that's close to that without, getting a meteorite? I think they still struggle to make those patterns on Earth. And using those cross-hatching techniques that you previously saw, kind of started to kind of engrave surfaces to do that. You can see a bit of a detail from it there. And then obviously moving further into kind of software, started to kind of connect me with kind of software creators in software. So I was using 3D Max at the time. Again, quite an open piece of software, had a scripting function to it, had a kind of plugin function that was completely open. Anyone could develop their own plugins. Ended up working with a Russian programmer at one point who was coding stuff for me. And this was a fantastic plugin that was made by a brilliant craftsperson in Inverness, who makes like ski and do daggers. And you should look his stuff up. It does these amazing CNC daggers. And he developed his own little bit of CNC software to translate cut files. So I used a bit of that and a bit of this plugin, which enables you to draw directly onto surfaces to create these kind of very fine textured lines that look like they've been hand drawn. Well, they have been hand drawn, and using a ridiculously small sample rate on them. So you can see these kind of wobbles of the pen as I was drawing it. And then you can see how that translates into the metal in these pictures. I just flick between these two so you can see it better in this one. You get these ripples that look like they're potentially acid etched or hand etched, and then the machine kind of ones there. One of the interesting things on the machine patterns is, I suppose it's what you know as the maker behind things and what people see. People see these kind of patterns, and to get to that took an enormous amount of time because I wanted this kind of effect that was like the maps that we looked at earlier. So this kind of fading out effect of cut files. And that isn't how a CNC machine works. It creates uniform step overs. So if you set 0.5 mil, every single line is 0.5 mil apart. So I ended up having to make this 0.1 of a mil passovers, so increments as it rippled out, and then delete every single other one to create the kind of fading effect, and then rejoin them all manually, and then take out the passovers. So let's jump back a little bit. This line here that you see traveling across that surface, that's a passover line, and it's there as an automatic feature in the software to mean that this tool doesn't have to come off the surface. So that speeds up the machine in a normal operation. But you can see it's pretty brutal in the way that it travels across the surface. I didn't want that. So I ended up deleting all those and rebuilding them all so that it didn't have them. So little things like that, kind of, you start to pick up on the details, and it takes you longer and longer to work into this. And then I worked with Dr. Louise Valentin Dundee. It was a big project, past, present, future craft practice. And that was about timelines and journeys, and a kind of a little bit like today, like what I'm laying out to you, all these different influences across my past and my background and who I am as a person. And I think that really kind of changed things for me because it kind of, I suppose, brought the recognition that cycling was more important than I thought it was as part of my craft practice. I just saw it's kind of like there's cycling there and here's craft over here, and couldn't really correlate the two. And then actually, working with Adam, did a solo show in Edinburgh, Adam Paxson, the jeweler, and it kind of did this lovely film with me talking, and suddenly started to realize that cycling was this kind of meditative, contemplative space where actually I kind of de-risked the stakes of what I was working with. So I was going into these CNC milling projects, high risk, trying out things, breaking things, investing quite a lot of time, money, effort. And then you get to a certain point on that journey and you need to de-risk it because you've got collect in a week's time, or somebody's paid you a big commission and you've got to finish it, or, you know, there's a reason and you need to remove risk. And cycling kind of acted as that vehicle to help me manage that kind of process. And then something else really interesting happened on that, which was, I think, you know, I was taking a quite a control aspect of how I made things. So I would set on an intellectual journey, come up with an idea, digitally make it, respond a bit to some of the textures that were happening in the machine or the opportunities, and then press the green button and walk away. And then one day I came back mid-cycle. I just paused this object I was making here, and I was like, that's really amazing. I've never seen that. Never seen that halfway point somewhere on a journey between something I designed and something the machine has semi-engineered. So there's something interesting in this. And I decided just to take it out of the machine. And it's that kind of change in confidence to go, no, I don't need to finish something. And what is finished anyway? Just being mindful and responsive of the moment. And that kind of enabled me to kind of show other parts of the journey to the audience. And I think, you know, as we go to craft shows, the kind of hyper finish of things is quite scary. You know, you go in, everything's beautifully made and beautifully finished. And I'm guilty of that as well. A lot of the work, you know, it looks like it's arrived at a spaceship and you kind of wonder how did that happen? So I think it's important that some of the pieces also show that narrative behind the material, the process, and how it gets there. And certainly not necessarily beautiful in the traditional sense, or kind of aesthetically kind of considered, but kind of got this rawness to them that speaks of you know, kind of two worlds. And then at that point, I kind of moved into this other challenging world, which was a kind of series of bowls that spoke to my love of famous cyclists and landscapes. Campionissimo is a reference to Fausto Coppi, the famous Italian cyclist from pre-war time. Grand Galibier was made in a kind of memory of Marco Pantani, one of the most famous Italian cyclists, or the most famous Italian cyclist, let's call it that, still loved today. And we'll come to Robert Miller or Philippa York in a second. And you know, viewing kind of the Alps, I went to the Alps as a kid, as a teenager, walked across the Alps with my parents, saw some of these amazing places, these glaciers, these erupted surfaces, and went back in my kind of mid-20s and had the opportunity to cycle a lot of the famous climbs. And that was what really kind of brought me into these kind of pieces that were about these cyclists. I suppose not least because, you know, Italian culture was part of my growing up in Scotland. A lot of Italians settled there in the war or after the war. There's a lot of ice cream shops that we'd go to on our cycles. And, you know, Italian ice cream was great. And it was kind of a love with Italy from that moment. So these blocks of metal, these are the starting point, the billets as they arrive from the metal shop, 50 kilograms a piece. So, you know, you kind of have these ideas and then you get them and you think, I can't actually lift that. What have I done? So there then would be a series of kind of, you know, processes just to get it onto the machine, never mind actually making the thing. Test pieces, you know, small blocks of metal around about 300 mil really kind of helps de-risk the process of this. Looking at tool marks, being able to stop things and see what was going on, and then be able to kind of choose that for the finished pieces. So this is me just trying to make it workable, get it small enough that I can hold it. So for reference, the cutter that's loaded there is 60 or 6 centimeters wide cutter. That block of material is about 300 mil wide in total, about 500 mil high. And then that gets it into this state where it can be loaded into a 4th axis machine that can rotate it. So you can create asymmetrical objects or symmetrical objects. And you're starting to come up against all the limitations of the machine now. So the weight of the object, the worm screw inside this drive, just being about capable of turning 35, 36 kilograms at a push, vibrations. So, you know, anybody who does lathe work or has been on a lathe, you know, as soon as you get as far away from that clamping surface, things start to vibrate and wobble, and that's not good for mark making. And then these pieces took so long to make, about 3 weeks, that the thermal differences in the pieces became so challenging. And these profiles on the side were kind of reminiscent of the terrain maps that cyclists would stick on their stems before they start a stage. So they draw these little maps and they kind of go, well, there's a big hill in 50 kilometers. And this was the last bit of the piece. So I'd made everything, the inside, the outside, it's all made. And then you got this one operation to do, and you can destroy the entire piece in like 30 minutes quite easily. So that's where the feeler gauge came instrumental. So being able to feel the depth of the metal, do a test cut on other pieces of metal that were going to be cut off later, and just see what sort of line thickness you were going to achieve, rather than use the automatic tool setting, which resets all of the tools that you're using. So it's kind of like it's like a game of chance. It's like, do I trust the machine or do I trust myself? So a lot of cycling involved in this. There's some pictures of the inner surfaces, and this was one of the objects that I started to kind of use very large tools to finish the surfaces with. So rather than finishing them with a very small tool like a 3mm tool to get the same effect as in the digital file, I started using kind of 16 and 20mm tools to create a kind of a blend between the machine world, the digital world, and what I was imagining I would get. So the kind of real unexpectedness that you get here. Obviously extremely challenging to polish. I had to polish this all with cotton buds by hand, which wasn't fun. And you can see some other pictures of them here. And then there was one final piece that was in memory of Robert Miller, who Philippa York, known as Philippa York now. Great story is obviously I grew up, you know, in the same area as Robert Miller. Robert Miller was an engineer originally and used to kind of bunk off to go cycling. So kind of quite similar story. And I decided I had to go to the same place as his famous 93 victory that he had in the Tour de France and cycle it. And that became the kind of inspiration for the piece. So actually going there, seeing the terrain, feeling it, and then making the master sketches from all of those different pieces of data to culminate in this final piece. So some of the measuring tools that help take out the risk of the work, help measure all the different tools that you're using. So you might have 20 tools loaded in the machine at any one time. They all are measured in relation to one another. The setting bar helps keep things continuous. And then we go through a series of stages. So this is kind of looking at the stages of production. So what's typically known as a rough cut. So using very large tools to take off large amounts of material, followed by finer cuts, typically down to about 2/100th of a millimeter step over distances to achieve kind of almost mirror finishes. And then when you're kind of working in these spaces where you want to create a blend of the intentional, the haphazard chance effect, there's a lot of putting your hand inside things full of coolant, feeling things with your hands, seeing what sort of result you've got, cleaning it out halfway through a cut, polishing it a bit to see what it might look like, and then carrying on or pausing. So it's that kind of intervention, that manual intervention of opening the door, stopping things, checking things, deciding if that is an interesting result that you've got, and then carrying on. Because once you've passed that moment, that's that possibility gone. To get here is, you know, again, is maybe like another 90 hours. So you kind of, you're constantly evaluating where, you know, what to do and whether to keep what you've got or go for something else. Some of the very advanced tools that you use, this tool on the left is 3000, shrink fit Showa Japanese tool. Really long reach, no vibration, spin at 20,000 RPM and not wobble. So you kind of starting to work with these sorts of levels of precision. A ruby crystal touch probe is used to find the center of objects. So you can find out the exact centerpiece, even of these really complex asymmetric forms, as you can see here. And having to learn how to use these in order to do that, so you can achieve even wall thicknesses. And then designing things like this is a jig, a fixture jig to hold the object upside down while I machine the base. This is the inside surface. You can see multiple different pause points with large cutters and fine cutters, and then the base on the bottom there. And then final piece for today, and then we'll finish off for questions, is kind of really going the full journey with the machine story. So DPA is something that is destructive physical analysis. It's used in engineering terms, not often, to take something to the point of destruction to work out its failure point, used in aerospace mainly. I grew up walking the hills around my home. I used to find bits of aircraft. This is RN Fairy Firefly, which was in Muirshiel, not close to where I grew up. We used to walk here, I used to see these bits of wreckage, and I was kind of interested in that kind of failure point in terms of craft and what that meant. And I made this piece, just read out a little kind of descriptive thing that I wrote for it. Towering at its wafer edge, each layer shimmering, light dancing in all directions, a liquid surface flowing. The blade emerges, unyielding from its base, the plateau scarred by tools that nick, gouge and tear. Precision cutting unearths caves of glimmering alloy. The spinning teeth of an industrial saw severs the billet, scarred with digital ID, gunmetal grey, pitted and scratched. And I think that really kind of sums up what I was trying to capture here was the life story of this material. This is the digital identification of the bar on the side, and it was trying to not remove any of the marks made previously, the delivery marks, the manufacture marks, the tool holding marks. And again, this was really challenging. So this piece is 900 millimeters long, and about 300 high. There wasn't a tool long enough to cut it with. I had to buy tools mid-job because the ones I had weren't long enough. At the time I was making it, this, I suppose it will end on this. This was the interesting bit. I don't think I really embraced the DPA fully. I think, this is the final recollection for me, is that I should have just let it destroy itself. That would have been the kind of proper intellectual result of this. And there's a tear. It's just on the right hand top edge here. It's 0.2 millimeters thick at the top edge. The vibration caused it to tear, and that really was the kind of, is the failure point. That is the destruction starting. At the time, I think I wasn't thinking in that way, and I was kind of like, oh no, I've damaged it. I'm going to have to polish that out. So I think, in some time in the future, I need to revisit something similar and really kind of, take this to destruction point. So yeah, that's just the final edge there you can see of the piece. And this is the sign that you always know you can relax on. And it tells you can switch everything off. It's time to reboot. Thank you very much for listening, and looking forward to your questions.
Cheers, Drummond. That was brilliant. It's I don't work much with metal myself, in terms of milling metal, and the accuracies that you can get are absolutely phenomenal to be able to create all those patterns. What we'll do now, Drummond, is we'll give you a 5-minute break that I'm sure you're wanting.
Sure.
Get a glass of water, a cup of tea or whatever, and we'll come back in 5 minutes, and then myself and Eleanor will go through the questions from the participants. So we'll come back at about 8 minutes past 5.
Thank you. No problem.
Hey, Drummond, welcome back.
Hey.
We have a set of questions here from the people listening, but to start off with, I just wanted to ask you something. You mentioned at the beginning, or alluded to a few times, that how important it was for you to get first-hand access to the equipment. Of course, I'm sure for several reasons. That there's no technician that would have the patience to go through and do what you've been doing, but also you wouldn't have the knowledge to design what you've designed without having the first-hand access to the machinery. And I would agree with all of that. But I suppose, can you maybe say a little bit of how important it is for us to give access to students to firsthand to machines and equipment, rather than having, you know, ourselves as academic staff or technical staff as a buffer in between, to give them actual access and to allow them to break things if they need to, or drill holes in the beds of machines, as you said, whatever, because everybody needs that sort of access to be able to get confidence and to understand them properly.
Yeah, it's a real challenging dilemma, that one. I think, you know, obviously now seeing it as head of subject, from the flip side, obviously being responsible for our resources, along with my technical manager at Falmouth, I think, you know, it comes both ways. I suppose sometimes you see students who will flourish in that way. You know that they can cope with that open structure of creative play, and I think it starts much further down the path than where we are now at HE. So I think in my education, you know, the D&T department at school, there wasn't much there. It was like you probably had more files in your home than you did at the D&T department, and going to university was a real treat because there was so many resources to play with, and almost in a way it was the first time you interacted with those sorts of things. Obviously technology has trickled down much further in the journey now, and you know, we see milling machines and 3D printing and laser scanners and laser cutters in high schools across the country, some primary schools, and I suppose, you know, learning has changed quite fundamentally too. I think, you know, we see a generation of people, of youngsters, who kind of some of them want to be shown what to do. I think, you know, we're all guilty for that situation, and I think that's something that's developed over many years. It's not something that's just happened overnight and suddenly we had a one spike generation that didn't want to do it this way. It kind of feels like, as digital adults, we use that to be in more control of the tools our children were starting to adopt into. And, you know, we kind of, we want to know what they're up to. Whereas when I was playing in software, it was kind of on my own terms, because, you know, well, my parents and peers didn't really have a clue what I was up to anyway. So they wouldn't know if you were breaking it or not. Whereas now things are very kind of constructed. And I suppose it saddens me because I see kids come into us with like a USB stick. They've made it design and technology. And it's, you know, we know it works for the exam boards. And it's been set, and there's no sense of play. I think now that technology is coming to a price point that is more affordable, I think we can kind of see an end, hopefully, to this situation. I think, you know, that spike at which I was describing in my career, where, you know, when I went to the Royal College, a 3D printer that did resin was £250,000. Wow. It's not something you just bought, you know, for this. I think I'll have a 3D printer. You can buy something nowadays, an Elio Go, 500 quid, 200 quid, that can do the same as that £250,000 machine could do in those days. I think that, although it's not accessible in the true sense of that, you know, £500 is still a lot of money to find these days, it does mean that more youngsters are investing in it on their own terms. So we see people who are digitally creative coming to us at university, having a 3D printer at home because they've seen it and maybe as part of their Warhammer collection. They saw it as a cheap way to print Warhammer figures and they've made a business out of it. And it's a changing thing. I think I grew up in a kind of in a unique space, as we all do, and you become the person that you did because of the history you've gone through. And the digital people and makers that we're seeing nowadays, whether they're playing in Grasshopper or whether they're developing things in computer software or whether they're kind of making their own 3D printers to do new materials, it's a very different form of making from what I went through, but it has all of those essential elements to it, those kind of innovative quests to do things on your own terms and to do things differently. So I think we're getting back to a better place. But definitely, I think we went through a period in the UK for sure where machinery was a guarded, protected thing, and you only accessed it on the terms of the institution. And I think that's been damaging for creativity in that sense.
Yeah, and I think as well as the equipment becoming cheaper, there are many opportunities to build your own equipment now. There was obviously opportunities always to build equipment, but now parts are becoming cheaper. There's a lot more knowledge being shared online for people to buy kits and assemble them. And then once you've built your own kit, it's about confidence building that you then understand it and are happy enough to take it apart or fix it when something goes wrong.
Yeah, absolutely. And, I think even in my own children, I've got 4 kids under 13, and my youngest, they code their own Roblox games. They're only 10, and the skills that they develop, I could never do the stuff they're doing. And I think, the confidence that those sorts of skills will get us to in future. Now we're seeing people who are more competent with electronics and, like you say, happy to build their own stuff because they were exposed to that sort of ways of learning at an earlier age. So it's all good.
Drummond, I absolutely fascinated by the method through which you make things. It seems incredible, particularly at the end where kind of almost like chalices, with the kind of plain outside and extremely decorative inside. It seems, I wonder, when you consider that it was originally a big lump of metal that was etched away, it was almost erosion, where normally in that case it would be a flat piece of metal that's hammered away into something that's more 3D. Do you think that's something to do with your landscape, or that whole time element of being inspired by your cycles, your home turf? That's these things take time.
Time's definitely an important element in it, and the cutting process, the erosion process. I don't think it bothered me at the time. I think now, 10 years into leading a sustainability department in a university, my more recent work has looked at the environmental impacts of, so you've got bauxite, you've chosen to take a billet of aluminium that's 50 kilograms and you've cut half of it away and you're left with 5.5 kilograms. What happens to the rest? I don't think
that answers my next question.
Yeah, I don't think craft can be, wash its hands of sustainable responsibilities. And certainly I've been working with 3D printing agencies to create what we might term near net forms, which are the form of the object within, say, 2 or 3%, and then by using 3D laser scanning to create accurate digital versions of that, you can reverse machine into it the last fractions of a millimeter. And obviously that's saving 80-90% of the wastage, the energy used in the time of creating the pieces, the transportation of it, the processing of the ore, and so on. So I think I've become more aware of that. I think at the time I kind of enjoyed the fact that it took so long to make, because it kind of made it feel a bit like the madness of it. It's like, who would do that, I think now, yes, I mean, I still like that. I mean, I still enjoy that, but I'm aware that the environmental impacts of some of those practices are questionable, and you need to find other ways that can achieve similar end results, but do start to kind of improve the use of energy and materials.
But I assume all of the swarf is recycled in the end, and I also saw that you used it within an exhibition, so it does get used.
Yes, absolutely. I mean, we used to bag it up and sell it back to metal scrap yards. But yes, in some exhibitions, we've used it as well. I mean, I really like that kind of the visceral kind of sensory aspect of the cutting fluid's got a very particular smell to it. And the swarf is obviously, yeah, an important part of it too.
I have a question here from Jerry Murray. Stunning work. He says, step over and cusp heights are such underrated artistic tools. Are they the digital craftsperson's brush marks, do you think?
Yeah, I never get bored of them. I think that's what's so nice about the many permutations that you can achieve. If I take the fact that even if I just worked with 20 different cutters, there's millions of permutations that I can make from those. And I think that's what's kept me so fascinated and kind of inspired to keep looking for new textures and new mark making techniques, whether that be lying to the machine about what tool's in there, or lying to the software about what tool it has for calculating it, or changing tools halfway through. It's that kind of like slightly naughty child hacking mentality. And I think, that's what creativity is all about, isn't it? It's kind of trying things out and seeing what interesting stuff happens. Sometimes you get, a real dog's dinner, and that is part of it. You kind of need to be able to recognize what doesn't work. And I suppose, like Eleanor was saying, there sometimes the process, you can't just let the process be the whole thing. I think what is still part of me is that aesthetics are very important. The idea is very important, and the finish of the object is very important. I think even in that final piece, just looking back on things, sometimes things are unfinished business as a craftsperson. They're just a slightly more advanced prototype on the way to something else. So definitely some unfinished business there. But yeah, I think step overs are definitely something that aren't talked about enough, and tools. I think, I see it in my own workshop with students. Okay, they're making things for different purposes sometimes, but they'll often just take a 10mm and a 6mm because that's what's in the box. So I think, just having that confidence to question those things is part of it.
Just to make it clear to anybody who's listening, some of the terms you might actually fully understand. The step over is when the bit is moving, then it moves on to the next track, and then that movement, that amount that moves, is a step over onto the next track that it cuts, and then the next track that it cuts. So you've been adjusting those to create the lines in your work. Is it always aluminium that you use, Drummond?
Yeah, I've had many people over the years go, why don't you do this? Why don't you do that? And I think for the reasons that I laid out in the talk, I grew up with that material. It's part of kind of me, mountain biking, cycling, engineering components, aerospace. It's the material that I love. So I kind of never really been that interested in other materials. I've dabbled in them, but they don't hold the same. It's kind of forgiving and not forgiving at the same time, aluminium. It's quite easy to cut. You can cut through it like butter if you've got the right tools. But it also picks up any misgivings in your cutting. So any vibrations. There are different ways a tool can cut. It can cut into the material, climb cutting, which makes the metal chip better. So you get lovely clean bits of swarf and very sharp cuts. And then you have another sort of cutting which it pushes against it. So it's almost forging the metal out of the way. It's kind of like pushing and compacting it out of the way. And depending on the rigidity of your machine, you can kind of get away with that or not. in different metals like titanium or steel, you might be able to achieve it. With aluminium, you see any vibration straight away. Certainly with the 3D printed pieces, been looking at other materials, so working with stainless steels, marine grades, and titanium grades. Much easier to cut than I imagined they were going to be. I thought they were going to be like, really tough, but not too bad with the right cutters.
Just a practical thing, the mill finish on aluminium, that kind of black hands you get from like, do you have a finish, or is it that like it's just
if you
shines up lovely, but like you I don't know.
Yeah, so when you cut it, as long as you protect it from oxidization, so one of the important things when cutting is obviously the coolant is an oil-based coolant, and it was always very important to leave the coolant in situation until you had time to take all the piece out of the machine, degrease it, wash it, dry it, lightly kind of treat it with a cloth. But then that's it. There isn't any extra work to do. You don't need to polish it. It comes out polished because the cutters are so sharp. If you leave it in the air, it suffers from kind of metal corrosion. So if you had steel contacting, you might get biometallic corrosion on it. In terms of museum collections, obviously they do look after them. They keep them in quite low humidity boxes, and I think this is the other thing about digital objects. Mine, I suppose, a little bit less complex than some other makers. Is the museum archival trade has probably had to kind of adopt new practices to understand how to look after, particularly some of the 3D printed objects. And certainly, the people I've worked with in the museums have been great at kind of helping understand how to best look after these things. But certainly not any. Yeah, there you go.
No, just a question there from Tatiana, because I'm kind of commandeering all your time. She wanted to know what was your favorite work, and if you had it just there to hand, which ones? Yeah.
Favorite work. I really like that the com piece. I think that was the final bowl I ever made. I'm one of those people who do something until the point I don't learn anything new, and then I stop doing it. So I'm never going to make another bowl again. That's them done. And people will phone you up and they'll go, "You're going to make another one of those?" Like, nah, done now. I've learned everything I can learn about that. I'm on to something else. And I think that was the point at which everything that I was learning through the earlier pieces, I kind of felt like I had the full palette in front of me when I was making that piece, and I felt kind of everything was working in the way I wanted it to. I think Terrain Cup has always been a favorite. I think it was like the first piece that I made on that machine. It was special for that reason. I think the fact that was it Thomas Goodison helped procure it for the Crafts Council, and just feeling that I kind of the digital forms had a kind of place within craft culture in the UK, was kind of cemented by that kind of purchase. And I don't know, that was kind of quite special for me, because I do ultimately make them mainly for myself, but I have always believed that museums and collections is the best place for them. I do feel slightly sad when they go to private collectors, other than Charmaine, who's obviously been very good at sharing them with museums all over the world, because I think growing up and going to museums, you can see a heritage of engineering or of craft or of design from your area or from across the world locally. And I would always go to the Royal Scottish Museum as a child, and having my own work there, it's kind of nice. You feel like you're part of that journey, and yeah, that's very rewarding.
Drummond, I have a question here from Chloe Dowds. Thank you for such an interesting talk. You spoke about craft objects often appearing highly finished in exhibitions, and later on you spoke about trying to emulate hand-drawn lines on your machine. It seems the craftsperson highly finished, it seems the craftsperson's highly finishes pieces to show their skills, like they were almost as precise as the machine, while sometimes machines are trying to emulate a handmade look. Can you speak a little bit about this?
Yeah, absolutely. You know, that's a really good observation. You know, and it is that kind of dichotomy kind of position. I did that when I was hand making. I used to try and make things like a machine. I think when I used to go to the museums, I would see things that had been made by hand, maybe centuries old, that were so exquisite. And I just struggled to understand how I would ever be able to achieve that, because at that time, when I was maybe only 17 or 18, I think for me, craft was about technical excellence and achieving technical excellence and not much else. Then as I started to understand it more as a kind of intellectual inquiry, I think that kind of confidence to kind of move away from that need to finish things so precisely started to occur. I think, you know, what we're speaking about in terms of the machine thing, it's certainly a disruption. I think, you know, what digital makers are always trying to do is trying to subvert the tools, their original purposes. And depending on the tools they work on, you know, there are very different industries that they've been designed for. And creatives like to mix things around. They like to take something from computer gaming industry and mix it with something for the fashion industry and come out with something for jewelry. That's what's so poetic and beautiful about that, the kind of discipline. So yeah, I do recognize that. I think people are trying to create their own unique identities, and hand making, I think we still read that as things that are handmade have a personality, a unique identity about them. And I think that's what I've tried to do. I've tried to achieve a personal vocabulary through digital means that is not non-repeatable by other people, but extremely difficult. And good luck if they want to. They're probably madder than I am. And yes, you know, I think there's value in people in the digital world trying to do that. I'm not sure how much value there is in going the other way, because it's kind of like that endless kind of pursuit of trying to get precision. You know, I think I failed eventually to try and do that, and machines offered me a way to kind of go beyond that, to augment, you know, what I could do by hand.
Tashita, David, love your work and the different approaches you have to making. Just wanted to ask, who are your client and customers and how do you find them? Could you tell me more about this project with Adam Paxson? I'd love to hear about your collaboration with a jeweler. Thanks.
Sure. Let's start with the last bit first. So Adam was, that was a really interesting, opportune kind of meeting. So Adam was commissioned by, I've forgotten now, Scottish gallery, the Dovecott, to make a series of solo shows by artists. And I was one of the first shows. It was called Matter One. And Adam was, it was kind of a project to help people progress in their craft career. So for me, it gave me an opportunity to have that space to be a solo artist and to do everything I'd always wanted to do in an exhibition, because up until that point, you'd always been part of group shows or curated shows with other workers. And working with Adam really kind of enabled me to kind of design a solo show that had all elements about my personality and what I do in my process as part of it. And for Adam, it was very much an upskilling as a curator. So Adam's career trajectory was moving him from being a jeweler, a and if you know Adam's work, you know, really beautiful, colourful, acrylic, polished, handmade jewellery, into that other part of life of being able to do curatorial practice. And I think, you know, this is one of those important challenges for craft, is that I see it time and time again, is that friends who are crafts people in jewellery either get stuck making things, the same thing over and over again because there's no other way to make ends meet, or have to do other jobs alongside things. So lecture and be a jeweler, or lecture and make things, or work in a shop, and it's a hard life. You know, I think when you're going through it as a student, it's great, it's lovely, it's really playful, you express yourself. But when you come out the other end, I don't think we haven't found a support mechanism for craft. We haven't found a place of how craft connects like it used to. And maybe that's a fault of how it's split. You know, if we see craft as a way of just making things, and now we also have craft as an art form, we see its purpose in galleries, we see it as collectibles. We don't also necessarily always see it in that same envelope as functional objects, part of Etsy, so on and so on. And craft's all those things. So kind of getting to the point about the money bit of things, I don't go looking for people. I suppose it's never been my objective to make a living out of it. I suppose in a way I don't like the tension between feeling like I need to do something for other people because I feel it treads on my own space, my own creative space. And I like to be able to define what that space might be, and to be able to say, you know what, that's the last bowl I'm ever making. Deal with it. I only need to say that to myself. I don't need to say it to a gallery. And I've had many galleries say, oh, you know, we'll represent you. And I know Petronella Wesker represented me at all the collects. And she was very good because she came from an art background. She understood that it was going to be different, and that 1 year on the next year could be completely different. And she did a great job at having the conversations with people like the Art Fund, which enabled you know, Shipley to purchase one of the pieces, Royal Scottish Museum, Ironbridge Museum. She knew the people in those networks. So I think I very much owe it to, you know, to Petronella for where the pieces ended up. So yeah, that really, hopefully that answers that question about it. I certainly don't make a living from it. I suppose I'd love to one day, but yeah, doing another job at the moment.
We have a few more questions and then we'll let you go, Drummond. Benita Mystery has a question. Really like the idea of DPA in craft and manual intervention mid-process. With the digital files required to CNC, is there any way you could see the various stages of the milling, i.e. 10%, 40%, etc.? And if you could preempt and stop the milling at a desirable, interesting stage? So I think that's what you do.
Yeah, I think manually is the best way at the moment. I've tried some software simulations of watching a file cut. So in engineering, there's bits of software, VeryCut is one of them, which simulates a complete machine, how it moves, and what the thing you're cutting will look like at any stage. The weird thing is it's more used for things like collision detection in engineering. So it's about, you know, your expensive tool's not going to hit a clamp or a bolt and damage itself. And it's to kind of give reassurance there. It doesn't simulate that kind of quality of texture you might get from the tool itself. I think as we're now moving into kind of like, you know, AR and VR and mixed reality, it could be really interesting to have people working on projects in those spaces to kind of overlay what could be on top of what is, which is, yeah, love to work with someone on that in the future. I think that could be really exciting.
You'd have to stop lying to the software about what tools you're using.
Yeah, exactly.
There's a question here from Roland. So I suppose if you were to start out on this, at several points he feels it was quite complicated. He wants to do some CNC work on wood, but kind of feels intimidated. Is there a stage before this where you could maybe use simpler techniques, like how would you introduce this method into your crafting, I suppose?
Sure. And I think, that is one of the things that relates a bit to that comment I said about, finished objects can be quite overwhelming. You go to a show and sometimes it just puts you in the wrong frame of mind, the inspirational to look at. But if you're a maker yourself, you sometimes wonder how you might get to there. I think the important thing to say is, I started milling in 1997. How many years is that? A lot. When I started, some of the objects, they were horrendous. They didn't look great. There was lots of mistakes. I didn't understand the software to the level or degree that I do now. The way to begin is to start with one part of the process and just explore it. Do your own creative exploration with that. And see things that interest you and follow them. All I've done is just layer more elements of software or more levels of kind of knowledge about electronics or thermal compensation as I've gone, only because I felt like I dealt with the first piece of knowledge about understanding how to cut the material and what marks it might make, right back in 97 or 2004. So I think, have a go. I think, like Michael says, some of the, the ready-made machines. I've got a student at the moment who's built an amazing thing with a DeWalt router, for a couple of £100 in his garage. And he makes his own, milling, mainly for sign writing. But yeah, have a go and have a play with it and see how you can add to your own practice. And I think, with anything, all processes take time. I'm sure if you look at your own practice of where you are today, you didn't just get there overnight. It took, a couple of years for you to become competent with what you do currently. And it'll be the same with digital. There's no, kind of fast, easy wins.
There's no press a button. It'll know what it wants to.
No.
Nuala actually has a question that's very much related to that. Is it possible to carve into any material, or would there be problems with heat, etc.? So it is possible to carve into pretty much any material. You just have to use different machines and different bits to do that.
Yeah, absolutely. And, I think, the Princess Diana Memorial is one of the most kind of well-known projects that's in London, where they rock engraved 3D surfaces for part of the ellipse that it makes the waterfall for the memorial, and that was CNC carved with special rock tools. So yeah, you can do things like granite. I dare say you can do glass if you have the right emery coated bits. So yeah, I think most materials can be cut. Yeah, and some things take a long time. So steel is tough, and stainless are very tough. And typically you don't see a lot of three-dimensional forms in those materials. You see what we might term 2.5 dimensional cutting, which is imagine a kind of profile shape that goes down straight to a particular level. Because that's quite easy for the tools to do. But starting to profile things three-dimensionally to create surfaces puts a lot of stress on the edge of the tool. So you don't see that so much in metal. Aeroplane blades are ground, so they use carborundum discs to grind the stainless steel into the turbine blades, which if you ever get a chance to visit a machine shop, it is a phenomenal process to watch.
One last question, Drummond, and then I'll let you go. You kind of showed towards the beginning of the talk the process that or the softwares you were looking at maybe 15 years ago, what's the process right now? Like, do you draw a 3D digital model and then overlay using another software the lines on top of that? And what softwares are you using to do that?
Yeah, I mean, different projects take you in different routes with the software. I think I'm not wedded to any particular softwares. I kind of look at the idea I want to make, and then I'll have a play with a couple of bits of software to see what tools are in there and what they enable me to do. That might be something like Rhino. It might be something like 3D Max. I've used Mudbox in the past, a kind of a painting software to kind of alter surfaces. I might use 3D laser scanning as a starting point and take a kind of an existing object to create a form and then work into that. So yeah, all sorts of software, and really I think there isn't one size fits all software. I think typically you'll move between the bits of software, because something like Rhino, for example, has lots of great little plugins that let you use it in different ways. You can see the open sourceness there. The whole Grasshopper movement's been phenomenal for architects and algorithmic designers. And Max has had that in the background in its history as well. So I think an openness to a software is good, because that other creative practitioners are working in that space, and it's not just the software developers dictating to you what they want you to do.
I think with our interpreters, they come from different regions, so we might have to.
We could probably talk all night, but thank you very much. That was fascinating. We absolutely love the work, and everybody's commenting how fantastic the work is. Thank you very much, and hopefully we'll talk to you again sometime.
Thank you very much. Thanks for listening, everyone. Have a good evening.
Take care. Bye.